And welcome back. So continuing with this topic, which is on structure and bonding, in this video we're going to look at covalent bonding. So hopefully by the end of this presentation, you should be able to give a definition for a covalent bond and have a general idea about what a covalent bond actually is. And should be able to draw dot and cross diagrams to represent single, double, even triple covalent bonds. So just as a reminder, this is the general IGCSE thinking for what the three types of chemical bonding are. We're going to be focusing on covalent bonding, which for the most part is bonding between two non-metal elements. So first of all, let's have a look at how we sometimes represent covalent bonds. So let's just look at a very simple covalent molecule, chlorine, Cl2. So there are two main ways you might be asked to represent a covalent bond. The first one is just a straight line in between the different elements. The second is by dot and cross diagrams. Now, with your dot and cross diagrams, you could also see it without the circles. And some people even do it without the extra electrons. They only show the bonding electrons. Although I would advise against this last one, I don't really like it. But either of the first two are fine. I prefer putting in the circles, which is what I'm going to continue doing. I think it shows the overlap between the different elements better. But if you prefer this version here, that's also fine, as long as you get the right amount of electrons in the right places. So what actually is a covalent bond? Okay, at GCSE, you would probably have gotten away with something like saying it's a shared pair of electrons. At AS level, you won't get away with that. Definition is a little bit more complicated. So covalent bond is the electrostatic attraction. Remember, this is just the attraction between something positive and something negative. The electrostatic attraction between the nuclei of two atoms. Nuclei is plural of nucleus. And the shared pair of electrons. So it's attraction between the positive nuclei of an atom and the negative shared electrons. So remember, one covalent bond is one pair of electrons. A double bond is two pairs of electrons. A triple bond is three pairs of electrons. So let's have a more detailed look at how to draw dot and cross diagrams. I will carry on using chlorine. So if we represent a chlorine of atom using your GCSE atomic structure, it would look like this. Chlorine is in group 7, it has 7 electrons in its outer shell, so you would represent it like this, each cross being an electron. Remember, when you draw your second atom, you should use dots, hence dot and cross diagram. This makes it easier to see where the electrons have come from. Now, neither of these atoms have a full outer shell. Remember, it allows the chemical to be lower in energy with that balance if it has a full outer shell. Now, given that we have two non-metal atoms here, it's more likely that there will be covalent bonding, sharing of electrons. So by each chlorine atom sharing one electron, they effectively have a full outer shell. So this here is a shared pair of electrons representing the covalent bond. So let's look at this in terms of your more advanced knowledge of electronic structure. So electronic configuration of chlorine, electronic configuration of neon, 3s2, 3p5. So I'm going to draw the orbital diagrams for these two elements. This atom I'm going to do in green. Now I'm only going to do the diagrams for the third shell, because the outer shell is where bonding occurs. I'm going to draw this atom in red. Now I know we don't normally draw 3s on top of 3p. This goes against how much energy these levels have. But I'm just doing it to make it easier to explain the point I'm trying to make. Now you can see that each of these atoms has one orbital that is unpaired. So these orbitals need to be paired up for the element to have a full outer shell. So the atoms overlap these two orbitals so that they are both effectively filled. You have paired up that orbital. Okay, so a covalent bond is actually the overlap of different orbitals. So now effectively each atom has 8 electrons in their outer shell. You'll notice that the left hand side chlorine atom has 3 lone pairs. So we have one here, and one here. And the right hand side chlorine also has 3 lone pairs. One here, and one here. So hopefully you can now start to merge the information that you had from GCSE with the new stuff you've learned at AS. So let's do the same thing with a second example. So let's look at water. Now, water we know is made up of oxygen and hydrogen. So let's draw out the electronic configuration of oxygen. So oxygen has the electronic configuration of helium, 2s2, 2p4. So let's draw out these orbitals. So we have 2s2, 2p4. Again, I've just drawn the outer shell. Okay, now hydrogen is very, very simple. It's just the first element, 1s1. So hydrogen has one unpaired orbital. So we can overlap those orbitals to make one covalent bond. Hydrogen now has a complete outer shell, but the oxygen does not. So we need a second hydrogen. So this hydrogen can also overlap its 1s orbital with the 2p orbital from the oxygen. So now the one oxygen and the 2 hydrogens all have full outer shells. So let's represent that with a dot and cross diagram. So oxygen has 6 electrons on the outer shell, including 2 lone pairs and 2 unpaired electrons. First hydrogen has 1 electron in its outer shell, as does the second. So you are effectively pairing up the unpaired electrons. So a dot and cross diagram for water would look like this. So each hydrogen now effectively has 2 electrons in their outer shells because they're sharing one of the oxygens. The oxygen makes 2 covalent bonds and then has 2 lone pairs, which are represented here and here. So that's a dot and cross diagram for water. So let's have a look at a slightly more complicated example. Let's look at O2, oxygen. Now we've just seen the electronic configuration of oxygen is this. So I'll just quickly draw out again the orbital diagrams. Now with oxygen, there are 2 unpaired orbitals on each atom. So what we can do is pair up both of those orbitals. So in this case, we have 2 shared pairs. Therefore, there is a double bond in oxygen. So again, let's just represent this as a dot and cross diagram. So it would look like this. You can see that here in the middle, we have an overlap containing 4 electrons, which is the 2 covalent bonds. Then the left-hand side oxygen has 2 lone pairs, which is represented here and here. And the right-hand side oxygen also has 2 lone pairs, represented here and here. So this is how we would show a double covalent bond. And if you're doing it with the lines, it would just be 2 straight lines. And last but not least, let's have a look at nitrogen. Now nitrogen exists as N2 gas. Now electronic configuration for nitrogen is configuration of helium, 2s2, 2p3. So let's just draw out those orbital diagrams. So we have our 2 atoms of nitrogen. Now you can see here there are 3 unpaired orbitals. Therefore in this instance, we are going to overlap 3 sets of orbitals. Now apologies, my boxes haven't been particularly neat in this example, but you can see the major point. We now have 3 overlapped orbitals. We have 3 shared pairs of electrons. We have 3 covalent bonds. And when we have 3 covalent bonds between the same atoms, we call this a triple bond, or a triple covalent bond. So again, let's just draw this as a dot and cross diagram. So nitrogen has 5 electrons on its outer shell. So this would be how you'd represent the triple bond. In the overlapped area here, there are 3 pairs of electrons representing the triple covalent bond. So that would be these 3 pairs here. Then the left-hand side nitrogen has 1 lone pair, and the right-hand side has 1 lone pair. So this would be a triple bond. So if you were drawing it using just lines, it would look like this. 3 straight lines in between the 2 atoms. Okay, so now we've looked through how to represent single, double, and triple covalent bonds, and we've tried to link it to the new information you've learned this year in terms of orbitals and the electronic configuration. So hopefully, you should be able to give the definition for a covalent bond, and you should have an idea about how we pair up electrons so that they are shared in between the different atoms. And hopefully you can now draw dot and cross diagrams to represent single, double, and triple covalent bonds. If you're unsure about any of this, have another look through the video, and I'll see you in class.